find the 6th roots of -1.
Okay, so this is kind of fucked up. It's kind of weird that he's asking you about this, but this green mark is not going to work, is it? Sad. All right, the 6 roots of -1. I can go that way. 6 roots of -1 is kind of annoying. So let's talk about square roots first. When I said solve x squared equals 4, you tell me that's x equals plus or minus 2, right?
Mm-hmm.
So x squared has 2 roots. Two. Has 2. No.
Oh, sorry.
That's fine. I got confused. All right. And you can see this because you could rewrite this as x squared minus 4 equals 0, and you have a second degree polynomial. And it turns out, this is a fundamental theorem of algebra that, this is called the fundamental theorem of algebra, that for an nth degree polynomial, it has at most n complex roots. So we're going to have at most 2 roots, and there they are, plus or minus 2. X cubed equals 8, you would think, okay, that just means x equals 2. It's not really plus or minus 2, right? It's not negative 2 cubed gives me negative 8. But turns out, how many roots would we expect, at least according to the fundamental theorem of algebra?
3.
3, because it's a cubic polynomial. It's a third-degree polynomial. We should expect 3 roots. But we can only find one of them. So the question is, where the fuck are the other 2, right? So that begs that question, where are the other 2 roots? So the way we're going to find that out is using the unit circle kind of idea. Here's the premise. Here we got a circle. We're going to say that here's 2, 0. That's a root that satisfies that polynomial. Okay?
Okay.
Now, a guy came along by the name of Dumois, and I don't know if I might have even talked about Dumois' theorem. You're not going to even write this down, but this Dumois' theorem. He came along and he said, okay, well, the way you can find the other roots of any polynomial are knowing that when you find one of them, the remaining roots are evenly spaced around the unit circle. So here's 1. There are a total of 3. So how many degrees will they be separated around the unit circle? We know there's 360 degrees in the unit circle.
Mm-hmm.
We divide it by 3 because we expect 3 evenly spaced roots. We should expect each root to be separated by about 120 degrees. Okay? So one's going to be here, and one's going to be here. Now, this might not make any sense to you. Well, first of all, let's go ahead and do some quick right triangle trig. If this is 60 degrees, because this is 120, so this is 60, you'll find out this coordinate is -1, comma, square root of 3. And you'll find that this coordinate is -1, comma, negative square root of 3. We have to switch to black, because as much as I want to use color, it's just not showing up. So there's these other 2 coordinates that are evenly spaced around the unit circle, away from 2, 0. But you're wondering, well, how do those translate into roots of that polynomial? We're going to convert this into complex. So this is the root -1 plus I times the square root of 3. And this guy is -1 minus I times the square root of 3.
Okay.
What am I doing? All I'm doing is I'm taking that number plus I times that number, and I'm taking that number plus I times that number. You can also say this is 2 plus 0 times I. What's 2 plus 0 times I? Just what?
2.
2.
Okay.
So the other roots of this polynomial, if you take them and you slowly but surely plug these, or FOIL this out, I suppose, I times square root of 3, and you cube this and you subtract 8, you will get 0.
Okay.
So what would it mean to find the 6 roots of -1? The 6 roots of -1? Well, we're going to do that is we're going to again start with, it's actually kind of tough. We have x to the 6th plus 1 equals 0. We're going to find the first root, and then we can know that the rest of them will be even. Once we find one root, we know the remaining roots will be evenly spaced by how much?
360 divided by 6.
Yeah, so 60 degrees, right?
Yeah.
But I don't know what this would be. You could say
He did something with like e to the pi k I x
we
stuff.
can talk about that too.
Okay.
We're going to take the square root of this or the 6th root of both sides, and you get x equals. Turns out the 6th root of -1 is I, but I'm trying to figure out how you might know that. Here's one way you could do it. Well, it's not the best way. What we're going to do is we're going to, here's the result we want, -1, 0, right?
Mm-hmm.
We want the result of x to the 6th to be -1. It turns out that when you cube something, shit, it's going to be really confusing for you. Let's do it this way. If I cube something, currently this displacement is 120 degrees.
Yeah.
If I cube something, it triples that distance around. So it brings me from here, 120. Tripling that distance means I'm going 1, 2, 3, and it will bring me back to a real number. What about tripling this distance? This is 240, so I would go 1, another 240 is 2, and another 240 from there would be 3. Make sense?
Okay.
Currently, how many degrees is this guy located at?
0.
What if you triple that? What do you get?
0.
0, so you still be at the same spot. So we have to think what angle over here would be such that when I cube it, or sorry, not cube it, rather raise it to the 6th power, or that is multiply it by 6 would give me, how many degrees is this over here? This is 0
180.
180. What times 6 is 180?
30.
30. So this is 30 degrees. And that corresponds to our first root. So let me repeat what I did there. I knew the result I wanted was -1, right? I want the result to be -1, right?
Mm-hmm.
So, and because I'm raising it to the 6th power, I know it must have come from some angle that when I 6-tupled it, it gave me this angle. What angle when you 6-tuple it gives you 180? 30. So that means this would be one of my roots. And if I do some trig, you can find out this coordinate is square root of 3 over 2, comma, 1/2. Yeah, comma 1/2.
Okay.
Now, like you said, once we find one root, I can find the others by evenly spacing them around how many degrees? 60. So this is 30. What's 60 more on top of that? 90. There's one here. This would be 0, 1. Let's do 60 more. That would be over here. That would be negative root 3 over 2, comma 1/2. 60 more puts me over here. That would be negative root 3 over 2, comma negative 1/2. 60 more puts me here. This would be 0, comma negative 1. And 60 over here gives me root 3 over 2, comma 1/2. Or negative 1/2. So how do these translate to roots of this polynomial, or roots of -1? 6 roots of -1.
So you say like square root of 3 over 2 plus
Okay, marker.
1/2 I or something?
Yep, that's exactly right. Square root of 3 over 2. The roots are x equals square root of 3 over 2 plus 1/2 I. What's another one? What's this guy?
I?
That's what I said earlier, right?
Oh, okay.
How about this one? Negative root 3 over 2, comma, or rather, plus 1/2 I, and so on and so forth from there, right? This would be...
Okay, yeah.
Got it? I don't want to write them all down? Okay.
No.
And that's how you find them. So let's try one a little bit like that. Let's try the 8 roots. Can I erase this?
Yep.
Let's find the 8th roots of -1. Actually, let's just do negative 256. As a brief aside, 2 to the 8th is 256. All right. One other thing I didn't mention was that it turns out, in addition to, so there's this additive factor with the angles, where you're tripling or adding the angles to get as we scoot around. When we, as far as the distance is concerned, that gets exponentiated, that gets powerized, I suppose. So that is to say, how big is this number? What's the magnitude of this number? It's 256, right? So that means if we take the 8th root of that number, you get down to what? What's the 8th root of 256? 2. So that means the roots have magnitude 2. And this is kind of confusing because you looked at a number like 1 plus I times square root of 3, and you're like, what's this guy's magnitude, right? When we talk about magnitude, we're thinking about distance from 0. So 1 comma square root of 3 would be here. There's 1. There's square root of 3. What's this length of this hypotenuse?
The square root of is 2.
2, right? So it turns out the magnitude of this number is 2.
Oh, okay.
Cool. Kind of neat, right? And that kind of goes back to what I was talking about before. Remember, x to the 3rd equals 8.
Mm-hmm.
The roots were 2. Obviously, cube root of 8 is 2. That one's easy. 1 plus I root 3 was another one, right? Or it was negative 1 plus I root 3. As you can imagine, that also has a magnitude of 2. And the other one was negative 1 minus I root 3. Also has a magnitude of 2. So that's kind of cool, right? So over here, we have x to the 8th equals negative 256. It turns out, how big is that number? Its magnitude of that number is 256. And because you're raising something to the 8th power, it must mean that the roots have themselves magnitude 2. So keep that in mind when we get down to that. Let's deal with the figure out the location on the unit circle though. So 8th root of negative 256 would be over here, right? It must have come from an angle such that when I octupled it.
Wait, what? Why is that?
Negative 256.
Okay.
Right. The result. So if I said you could actually do some crazy shit. You could look for solve that. So what would that mean? That would mean x equals the square root of I. That would be the square root of the square root of negative 1. How do we do that? We can get to that later, but not right now. But again, we have to start by saying, where is I? X squared equals I, where is I? On this guy? Remember, so this is your imaginary axis, this is your real axis. So this would be what number? What's the real part? You could say I is equal to 0 plus 1I.
Okay.
So what coordinate does that correspond to? What would you think? What coordinate is that?
Like that, like...
This one?
Yeah.
Yes. That'd be 0, 1.
Okay.
Negative 256, what's the real part? Negative 256. What's the imaginary part? Is there 9? 0.
Yeah.
So they don't go up or down.
Okay.
And remember, so we ask ourselves, what angle such that when I octuple it gives me, what angle does this correspond to?
180.
What angle when you octuple it gives you 180? What angle when you quadruple it gives you 90? What angle when you double it gives you 45? That'd be 22.5 degrees. Turns out I actually don't know those angles or the trig ratios for those guys off the top of my head right now. But then the other one would be, oh shit, what the hell? 180 divided by 2 is 90, divided by 2 is 40. Okay. The next one's going to be separated by, oh, right. What's 360 divided by 8? That would be 45.
Mm-hmm.
So there's one here, one here, one here, one here, one here, one here, and one here. There are those 8 roots.
Okay.
And they might be something like 0.89, comma 0.12, something like that. And so the corresponding root would be that would be maybe 1.89, comma 0.24, something like that. The corresponding root here would be 1.89 plus 0.24i.
Okay.
What's the magnitude of this? If you imagine if I squared this number, squared the 0.24, added them together, and then took the square root, what should I get?
2.5?
No.
No.
That's the angle.
2.
2, right? The magnitude. This circle is a radius 2 now.
Okay.
We won't talk too much more about that, but that's kind of the gist. If I start by plotting where this number is on a circle, and then ask yourself, okay, what angle when I multiply by that number gives me the location, the angle location of the number of whose roots I wish to find.
Okay.
Cool?
Cool. So now
Let's do one more. We'll do x squared equals I.
Okay.
What is the square root of I? That's weird. We know the square root of negative 1 is I. What's the square root? If I said solve this, that would be a little mind-blowing, right? Well, again, where's I located on the unit circle? What coordinate?
0, 1.
0, 1. Which corresponds to what angle measure?
90.
90. What number when I double it? Why double?
Because it's squared.
Squared. What angle when I double it gives me 90?
45.
45. So this right here is the location of my root. This corresponds to square root of 2 over 2, comma square root of 2 over 2. Where's the other one? Remember, they're going to be evenly spaced and by how many degrees?
90.
How many roots are there?
Oh, 2.
So they're going to be evenly spaced by how many?
180.
Yeah, so the other one's over here. Negative root 2 over 2, comma negative root 2 over 2. And here's what's fascinating. So this will correspond to what root? This would be root 2 over 2 plus I root 2 over 2, right?
Mm-hmm.
This is the square root of I. So your friends know that, many of your shitty friends know that the square root of negative 1 is I, right?
Yeah.
Do they know what the square root of I is, though?
No.
And they don't know that this is the square root of I. Let's show that this is the square root of I. If I square this, I should get I. What's root 2 over 2 squared?
2.
Nope. Square this.
Oh, so 1/2.
1/2. Plus, what's square root of 2 over 2 times square root of 2 over 2?
1/2.
1/2. So we get a 1/2 I from our outer multiplication. What about our inner multiplication? We get another factor of 1/2 I.
Mm-hmm.
And what's root 2 over 2, or sorry, what's I root 2 over 2 times I root 2 over 2?
1/2 I squared.
1/2 I squared. What is I squared?
-1.
So we get minus 1/2. So we have these 1/2s cancel. What am I left with? 1/2 I plus 1/2 I, which is crazy, right?
Yeah.
Fascinating. Cool. All right. We're done talking about this stuff, though. We can see how it pertains to differential equations in a minute.
Okay.
Do you want to stick with some second order polynomials first, though? Second order differential equations first? Let's look at some of the problems you wanted to do.
Oh, like these?
This is so 6 and honor would be kind of others. Okay, let's.
Yeah, I mean,
you can do this one.
Yeah, those are easy.
You can do this one. This one might be a little harder.
Okay.
This is third order. So how would you tackle this one? Was it third derivative?
Yeah.
Minus 3 second derivative?
Minus the first derivative plus 3y equals 0.
Okay, so in the same way that we had to figure out, this is our auxiliary equation, right?
Yep.
You're just going to apply the same principle as you learned from that to this. That we're going to try and factor this. Now you can, there's a couple ways to factor, one of which is factor by grouping.
Oh, so you could do the r squared out and then, yeah.
R minus 3 comes out of that. What would I factor out of this group?
-1.
-1. And I'll be left with r minus 3. I have the same pair here, so I have r squared minus 1 times r minus 3, which means my roots are what?
3 and plus or minus 1.
Yeah, you could factor that into r minus 1 times r plus 1. So you'd have r minus 1 times r plus 1 times r minus 3, and so those are your 3 roots. So what's your solution? You say c1 e to the 3t plus c2 e to the 1t plus c2, or c3 I should say, e to the negative 1t. And that's your solution.
Okay.
Just extending what we learned kind of a couple weeks ago to more than 2 roots. Now we have 3 roots or 4 roots.
Alright,
Here's one off the top of my head we should do. I'm going to make this quick. If I gave you y triple prime minus 6y double prime plus 12y prime plus, or rather minus 8y equals 0. This would have a corresponding auxiliary equation of this guy. This does not factor by grouping, but when you're when you're presented with something to factor like a cubic, you can make guesses. Your usual guesses start with 1 to -1, and if those don't work, you move on to 2 and -2. You can also use what's called the rational root theorem, which says the only rational roots will be of the form plus or minus the factors of 8 divided by plus or minus the factors of the coefficient of the r cubed term. Is that familiar?
Oh, yeah.
Like if I said 2x squared minus 7x plus 5, let's say 6 equals 0. The only roots that are rational from that, if there are any rational roots, could only be plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1 over plus or minus 2 or plus or minus 1, plus or minus 2.
Yeah.
That's the rational root theorem.
Okay.
Kind of familiar?
Yeah.
So that we can kind of use that to guide our choices. That if we see a 7 over here, we would know immediately that 2 could never possibly be a root, right? Because there's only plus or minus the factors of 7, of which there's just 7 and 1. And so 2 is not one of those factors. But since we have an 8 here, our guesses might be we might start with 1, which doesn't work. I'm just going to save you the time. -1 also doesn't work. And we move on to 2. Turns out when you plug in 2, we get 8 minus 24 plus 24 minus 8. Cancel, 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 cancel. That makes us very happy. Sure enough, r equals 2 is a root. So then how do we then factor that?
You can do long division. Long
division, or even better, synthetic division. So we're going to put a 2 here, a 1 here, a -6 here, a plus 12 here, just say 12 and a plus 12, a minus 8 here.
Okay, I never learned how to do that.
It's alright, we're going to learn it right now. So you put the root in a box up here in the upper left, and you put the coefficients of the polynomial in order of left to right. 1, -6, 12, and 8, -8, right? 1, -6, 12, and -8. You always bring down the 1, or whatever number this happens to be. You always bring that down. Bring that first one down.
Okay.
And then you proceed as follows. You take the number in the box, multiply it by this leading number, and put it up right under here. 2 times 1 is?
2.
And then you add. -6 plus 2 is?
-4.
-4. And then you repeat the process. 2 times -4 is?
-8.
-8. Add these, you get what?
4.
4. 2 times 4 is?
8.
The nice thing about this is that this addition here tells you your remainder. Well, we know this r equals 2 is a factor, or rather r equals 2 is a root, or that is r minus 2 is a factor. So we should know that it should leave no remainder. This is what we should expect. If you don't get a 0 here, you mess up your either synthetic division, or you were wrong about whether you were wrong about 2 being a root in the first place. Okay? What does this result mean?
Probably be r squared minus 4r plus 1.
Yeah, this is your what's called depressed polynomial. Need some Zoloft. It's the depressed polynomial is 1 power down. Make sense? So this is the cubic. Now and this factors in r minus 2 by the way. So it's a triple root.
Yeah.
So how would you write the solution, you think? Do you remember what we did when we had a double root? We said
you did the x,
c1
right?
e to the 2t plus what? What I said c2.
C, and then t.
And an extra factor of t.
Yeah.
E to the 2t. If you had to guess, what would you do for c3?
T squared.
T squared, yep. So every time a root is repeated, you add an extra factor of t.
Okay, so what if, like, I'm given this and I'm like, I don't know how to factor it?
Shouldn't happen. If that happens, you have bigger problems.
Okay.
You should know how to factor just about anything he throws at you.
Okay.
Okay?
Okay.
So let's try some of the harder problems now that I got that out of the way, just so I will clear up what happens when you have that kind of weird scenario.
Okay.
We did number 3.
Mm-hmm.
Number 6.
Okay.
Negative 5, 7, 3. Is plus 7 plus 3 or minus 3?
It's plus 7 minus 3.
Okay. Now, you could use that rational root theorem, meaning that if you try 1 and negative 1, you shouldn't bother trying 2 and negative 2, since the factors of 3 don't include 2, so you would skip that if 1 or negative 1 didn't work. But I think 1's actually going to work. Plug in 1. What's 1 minus 5?
Negative 4.
Plus 7 is?
3.
Minus 3 is?
0.
So indeed, 1 is a root. We're going to put this in a little box here. 1, 1, negative 5, 7, negative 3. Bring this number down. 1. And I'll have to get that set up, let you set that up.
Okay.
Put the 1 down there.
Oh, okay, yeah.
All right, now, 1 times 1 is?
1.
Negative 5 plus 1 is?
Negative 4.
Negative 4. Now you take 1 times this number and list it underneath the 7.
Okay, so negative 4.
7 minus 4 is?
3.
1 times 3 is?
3.
And sure enough, I get 0 here.
Okay.
The resulting quadratic is r squared minus 4r plus 3, which factors into r minus 1 times r minus 3. So what's my solution? Well, remember, our original guess was r equals 1, so this is a second factor of r minus 1. Does that make sense? So we should say c1 e to the t, that comes from this guy, the first root you could say, plus what? c2
t
e to the t. Good, because we have a double root, a double r minus 1. And then we move on to the 3, so that would be c3 e to the 3t.
Okay.
Good?
Yeah.
Is that easy?
Cool.
Let's see if I can pick out a harder one. This is actually almost legitimately this is the same one we did before. The t squared, this is e to the 2. Yeah. Came with that on my head. Same thing's gonna happen here except oh wait, shit, no. This is actually gonna be good. We should do this one, I think. Yeah. I think it's gonna be complex. We're gonna have some complex roots, which is good practice.
Okay.
I might be off now. Might be way off. This is it, right?
Yep.
I think you can factor by grouping, but let's just good practice doing synthetic division. Let's try what's a good guess. But first of all, our only rational possible roots could only be what?
Plus or minus 1.
And that's it. There's no other possible roots to try. Because there's plus or minus all the factors of 1 divided by plus or minus all the factors of 1. That's it. 1. 1 minus 1 plus 1 minus 1 is 0, so that indeed works. So we're going to put 1, 1, negative 1, 1, negative 1. You know, all these 1s flying around is going to make you dizzy. Setting my synthetic division.
Okay.
1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. Added to negative 1 gives me that 0. Cool.
Okay.
So that resulting depressed polynomial is what? R squared
minus r.
Ooh. R squared.
Plus 1, yeah.
Plus 0, r plus 1, right? R squared
okay.
plus 1. How does that factor? Technically, it doesn't factor.
Yeah.
It doesn't factor over the real numbers. Oh, by the way, how would it factor, though? If you could factor over the complex numbers, that would be r plus I times r minus I. They never taught you how to factor like this. They always tell you, oh, it doesn't factor, not possible. But now we're dealing with complex numbers, we might as well talk about it a little bit.
Okay.
If I said r squared minus 1, you would tell me r minus 1, r plus 1, right?
Yep.
Or actually, a little more generally, I said 25 here. You take the square root of that number, which is 5. You can say this. Square root of that negative of that number. So you take negative of that number, what's the negative of 1? That's negative 1. Take the square root, you get I and I. But you say r plus I, r minus I. That's how that would factor. Or you just do it the way we normally do it. Complete the square. Really not needed here. There's no completing the square needed because I don't have an r term. So I just matter of subtracting the 1 over. R squared equals negative 1 means r equals what?
Plus or minus I.
Yeah. Which kind of stems from this too, right? Plus or minus I. You got plus I from this guy, minus I from that guy. Right? What does that indicate as far as your solution goes? Well, let's actually deal with the first root we got. Namely, the single one, so c1 e to the 1t, right? What do the complex numbers indicate?
Oh, and then would you then plus e to the, no.
Well, you could say that. You wouldn't be wrong to say it, but what's my real term? What's my real number here?
0.
0. So you could say it would be e to the 0 t, right?
Mm-hmm.
And what do? Open bracket.
Yep.
What?
The cosine of I.
I'm going to need a coefficient.
C1.
C2. Or you C1?
Yeah.
C2 what?
Cosine of I.
Nope.
T.
What coefficient is of this I?
1. So just T.
1t. Yep.
Okay.
Plus what?
Sine of T.
We need another
So
coefficient.
C3 sine
C3 sine
of T. Okay.
T, and then you're good. That would be your answer. You can actually get rid of the e to the 0t because that's just 1. So that would be your answer.
Okay.
All right. Let's do this next one. We have this is where what we talked about in the beginning about those roots, how to find the fourth roots and so on and so forth. It's going to be really important.
Oh, number 9?
Yeah.
Okay.
So we have r to the 4th plus 1 equals 0. Okay. How do I factor that? It doesn't look easily factorable. I'm not going to factor. We're going to use that whole de Moivre's theorem thing. We're going to ask ourselves, what are the fourth roots of negative 1? The 4 fourth roots of negative 1. So r to the 4th equals negative 1. We're going to ask ourselves, where is negative 1 in our unit circle? What coordinate?
Negative 1, 0.
Negative 1, 0. Okay. And then you have to ask yourself, what angle when I quadruple it gives me 180.
Oh, 45.
45. So that puts us here. One root will be here. And that would be 1/2. Sorry, not 1/2. It's root 2 over 2, comma root 2 over 2. Where are the other roots going to be? Evenly spaced by how much?
360 divided by 4.
Which is?
90.
Mm-hmm. So there's some here. This would be 135 degrees. This would be 225. And this would be 315. So my roots are these weird, wacky 2 over 2, negative 2 over 2, plus. Okay. Negative root 2 over 2, comma root 2 over 2. This one is negative root 2 over 2, comma negative root 2 over 2. And this is root 2 over 2, comma negative root 2 over 2. So what are these roots? Let's do this. Let's write this on the left over here. What do the roots correspond to? Or what do these coordinates correspond to as roots go? The first one would be
square root of 2 over 2 plus I square root of 2 over 2.
Let's skip this one and go to the fourth one on the bottom right. That would be what?
Square root of 2 over. So okay, so you just do minus.
Yeah, plus or minus.
Right?
Right?
And you do minus square root of 2 over 2 plus or minus I squared over 2.
Exactly. I'm saying that these two roots kind of go together. I'm saying root 2 over 2 plus root 2 over 2i and root 2 over 2 minus root 2 over 2i are root 2 over 2 plus or minus I root 2 over 2. And these two go together. Negative root 2 over 2, negative root 2 over 2 plus or minus I root 2 over 2. What, as far as our solution goes, what does that correspond to? Let's start with the top group. That would be what? Y equals what? E to what power?
Square root of 2 over 2.
Square root of 2 over 2t. Open brackets. What?
Cosine.
C1
C1.
cosine of
square root of 2 over 2t.
Square root of 2 over 2t plus
C2 sine.
C2 sine. There we go. I didn't forget the C2 this time.
Square root of 2 over 2t. Yeah.
And this solution is due to this group of roots.
And then you like plus.
Plus.
Okay.
E to the negative root 2 over 2t this time for the second batch of roots. C1 or C3 cosine. I goofed. C3 cosine root 2 over 2t plus C4 sine root 2 over 2t. And that's how you tackle a problem like that. That would be a good test question because you have to, if he's really concerned with you finding the roots of the weird complex roots of a polynomial like this, like what are the 4 fourth roots of negative 1, he can implicitly ask you that in a problem like this because with doing this problem, you have to do it this way. You have to figure out those roots that way using that unit circle trick.
Yeah, I feel like he will ask.
Yep.
Okay.
Tackles just about everything.
Okay, so
there.
Probably
Yeah, the other ones you can do easily because they're all second order and they kind of go over. They kind of repeat what we did last time we met.
Okay, cool.
So, what? Any other is there a next page of homework problems, or is that it?
Oh, that was the first one, and then the next one is the new stuff.
Can I see?
Yeah.
Looks like a method of undetermined coefficients.
Yeah.
Okay. Let's just start with the first one. So these are non-homogeneous differential equations in that the right-hand side is not 0. The only way this differs from the problems we were doing before is that the right-hand side is suddenly no longer 0.
Yep.
So looking at that right-hand side, we see a 4x squared. When you want to find what's called a general solution to a non-homogeneous differential equation, you find the homogeneous solution and you find the particular solution. This is new. This is old. You should be able to find the homogeneous solution.
So it would be like r squared.
Mm-hmm. Yep. You start by finding your. So for this number 1 guy, this is what? Y double prime minus 3y prime plus 2y.
Mm-hmm.
And I'm going to go quickly with this. Y c1 e to the t plus c2 e to the 2t. That is your homogeneous part. And I just factored my auxiliary really quick. Again, you're probably going to get to the point where you can do that. Oh yeah, I can see that. That's r squared minus 3r plus 2. Factors into r minus 1, r minus 2. So I know my powers on t should be 1 and 2, and I'm done. Right?
Okay.
That's the easy part. That's the easy part. So you can kind of ignore that. To the particular solution takes into consideration what we have on the right-hand side. So this was equals not 0, but equals 4t, still say 4x squared. Or I say 4t squared. I know he says x, but we're going to keep saying t. All right. These right-hand sides we're always going to classify in 2 ways. The polynomial that's attached, sorry, I should say it this way. The exponential you see over here, the exponential or sine or cosine that you see over here, and the polynomial that's attached. Well, in this case, what exponential is attached?
Nothing.
None. You could even say this would be e to the 0t. Okay? You might think, why the hell is that important? Why not just leave it like that? You'll see later why it's important to know that this corresponds to r equals 0. I'll say now why. This is r equals 0. Does that match the r equals 1 or r equals 2 we got from our homogeneous?
No.
No, so I don't have to tweak anything. Which you might think, why would I ever tweak anything? You'll see. If it does match, then we've got some shit to worry about. But in this case, we don't. So I'm going to go erase it again and just say, you know what, don't care about it. Then, once we classify, we first classify by what kind of root. This would be r equals 0, because we don't see it at all. If I saw e to the 4t, this would correspond to r equals 4. If I saw e to the 41t, this would correspond to r equals 41. But I don't see anything like that, so this corresponds to r equals 0, and we're going to classify it like that. This would correspond to r equals 0, which is not match. You can say no match, which would be good, no match. That doesn't mean anything to you yet, but it will. And then you're going to classify further by the degree polynomial you'll see here. What degree polynomial do you see here?
2.
Degree 2 polynomial. What is our particular solution will assume the form of a general degree 2 polynomial. This is where things get a little hard because I'm going to say, what is a general degree 2 polynomial? We're going to use a as a constant, AT squared is close to a general degree 2 polynomial, but why is it not? A lot of people say, oh yeah, a general degree 2 polynomial is AT squared. Why is that wrong? Why is that not as general as can possibly be?
Why is that not?
It's not as general as can possibly be. Name another degree 2 polynomial. It could be a longer story than that. So say something like, start by saying a degree 2 polynomial.
Oh, it could be like 3t squared plus 2t.
Exactly. So then you can say something like what? Plus, have a guess.
Y of p or something.
No. Well, what do we use over here?
T.
We said
y of t.
We said AT squared, so we're going to say plus BT.
Okay.
And this story can go on, right? You could say
plus c.
Plus c. This is a general degree 2 polynomial, right?
Mm-hmm.
What this is called the method of undetermined coefficients. We are assuming the form of our particular solution because we see this popping out on the right-hand side. It couldn't possibly be degree 3 because we have a y here, and a t cubed would never get erased by something here. Think this way. Suppose for a moment that t cubed was part of our solution. There would be a t cubed in here, right? What's the derivative of t cubed, though?
3t squared.
A t squared term, right? Which would never get canceled by these derivative terms. So I have a t cubed here, but nothing in these would cancel my t cubed term. Does that make sense? Mm-hmm. If I have a t cubed term here, how would any of these cancel it? They couldn't because they're all these. If y is degree 3, what degree is y prime?
T squared.
T squared degree 2, right? And nothing from this would cancel the t cubed, which would be bad because how many t cubes do I have over here? No, how many t cubes do I have?
Oh, none.
None, so I damn well better not have any here. Nothing will be canceled. So we're going to assume degree 2 polynomial. We're going to run this through our differential equation. So we're going to take its first derivative and its second derivative. 2at plus b, and lastly 2a. So I'm going to take these guys, this is where I'm going to use colored marker, and plug them into their appropriate places in the differential equation. This guy goes here. This guy goes there. Alright, it goes there. I'm going to put it over here. So I have 2a minus 3 times 2at plus b plus 2 times at squared plus bt plus c. And what is the result supposed to be? When I plug all this in my differential equation, what am I supposed to get out? 4t squared. So we're going to start by grouping up powers of t. Well, what t do we see? We'll start with the words t squared. How many t squares do you see here? Where are you seeing t squares?
The 2at.
2at squared. So how many here? How many t squares are here?
2a.
2a.
And then you say that equals 4.
We have 4 t squares on the right, so that means immediately that a is 2. Okay?
Okay.
How about our t terms? How many of those do I have?
6.
Careful, not just 6, but
Negative 6.
negative 6a. And what else? Plus
2bt.
we have 2b t terms. And how many are there total on the right-hand side?
0.
0. Knowing that a is 2, we can solve for b pretty quickly. Negative 12 plus 2b equals 0 means that b is 6. Okay?
Okay.
And lastly, we're going to go with our co and st, or our constant terms. Marker's dying on me.
So we're say
Got a
negative.
Got a 2a.
Oh yeah, 2a.
Your 2a, a minus 3b, and a plus 2c.
Mm-hmm.
Needs to equal 0. We know a is 2, so we get 4 minus 18 plus 2c equals 0. 4 minus 18 is negative 14, so c is 7. So that means your particular solution is what? What's your particular solution?
2t squared.
Good.
Plus 6t.
Good.
Plus 7.
Yeah. So your general solution is this mess. c1 e to the t plus c2 e to the 2t plus 2t squared plus 6t plus 7. This is your particular solution, yp. And this is your homogeneous, so I should say yg here.
Okay.
Let's try another one. Does that one make sense though?
A little bit. It's a little fuzzy, but
Yeah, it's kind of a very algorithmic procedure whose steps you need to all memorize. It's kind of annoying. Let's move on to number 3. What is this? Wednesday?
yeah, we're gonna be going over those all Wednesday.
Okay. Let's skip to 3. I think that might be easily done in the time we have left. So it's a third degree polynomial, or a third order differential equation.
Yep.
Minus 3r squared plus 4. R cubed minus 3r squared plus 4. Kind of annoying. Let's start with r equals 1, right? That's what we usually start with. R equals 1.
Mm-hmm.
1 cubed is what?
1.
Minus 3 is?
-2.
Plus 4 is 0?
No.
No. Let's try negative 1. Negative 1 cubed is?
-1.
Minus 3 is?
-1. Yeah, 0.
Plus, good?
Okay.
So, negative 1, 1, negative 3, 0, 4. Bring down the 1. That's how that factors.
Okay.
R plus 1, r minus 2, r minus 2. So that means our homogeneous solution would be y sub h equals c1 e to the negative t plus c2 e to the 2t plus c3t e to the 2t, because it's a double root, it's repeated. So now we're going to look back to the right-hand side of this differential equation was 4e to the x minus 18 e to the negative x. So your differential equation was blah, 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 equals what? I should write the differential equation with y full prime minus 3 double prime plus 4y equals 4 e to the x or e to the t minus 18 e to the negative t.
Mm-hmm.
Okay. This has got to be classified 2 ways, or we have to split it up. So we're going to classify this guy first, and then classify this guy second. So, this corresponds to r equals what?
1.
Yeah. Is that a match? Does that match anything we have over here?
So what do you mean by that?
Did we see r equals 1 as a result of this homogeneous?
Oh, so if that
this was r equals negative 1,
yeah.
r equals 2, r equals 2.
Oh, okay. So if that was 2, so if that was 4e to the 2t.
Then I have a problem. And I'll tell you what to do. Actually, this one's going to match. I'll tell you what to do when we get there.
Okay.
But right now, r equals 1 does not match any of these, so I have to worry. So my particular solution, when I go assume it, I'm going to say y sub p equals. So now we've classified what this r is. I'm going to ignore it for a minute and say what degree polynomial does that correspond to? Is attached to that e term?
0.
Degree 0 polynomial. What's a general degree 0 polynomial?
C or A?
Yeah, A. So a e to the t. That would be our particular solution we're going to assume. Okay. Let's go over here.
So are you gonna have 2 of the y p's?
You're not going to just use separate ones. You're just going to combine them all at once.
Okay.
On one. It makes it easier. You could do them separately and find each of them and add them all together, or you just do them all in one fell swoop. We're going to do it all in one fell swoop. So this corresponds to r equals what?
-1.
Okay. What degree? Which is a match. So you say no. You can say no match here. You say match, and then draw like exclamation marks all around this.
Okay.
Hearts for eyes emoji. Whatever. It's a match. It's a big deal. We'll deal with that in a second. What degree polynomial is attached to it?
The 0.
0 degrees. So we're going to say b e to the negative t. But because this is a match, this is where the whole coup de grace happens, the finale. Because there's an extra factor of t here, or because there's a factor, because there's a match here, you need an extra factor of t.
Oh, okay.
That's a match. It matches that. So guess what? That match produces an extra factor of t in our particular.
Alright.
You could think of it this way. If I didn't have that t, I'd have b e to the negative t, right? How is that any different from c1 e to the negative t? The answer is?
Nothing.
It's not. It was not any different, right? This is just some constant. This is some constant. So we have to distinguish this solution for our particular solution from that in our homogeneous by adding an extra factor of t. Make sense? In much the same way that we have to add an extra factor of t because there's a match here.
Okay.
There's a match among the homogeneous roots that we have to add an extra factor of t. It just so happens here that there's a match between our homogeneous roots and the characteristic e on the right-hand side. We're at 356. I'm going to finish this up quickly. We're going to need to take some derivatives. Kind of annoying. We're going to need to take 3 derivatives. Pain in my ass, right?
Mm.
Fortunately, this is just 80 to the t all the way down. This is going to require a product rule. Yeah.
So you have to do that 3 times?
3 times, yep. Let's say bt to the negative t. Plus, and then you get b to the negative t. Okay, keep going. Why double prime? Plus bt e to the negative t. Derivative of this gives me another negative, so minus 2 b to the negative t. And third derivative, a e to the t minus b t e to the negative t, probably plus 3b e to the negative t. Okay, we're going to take this guy, put it here, take this guy, put it here, and take this guy, put it here.
Oh my god.
Alright, here's what's going to happen. Let's just start with the a e to the t's. I get one of them here, right?
Mm-hmm.
Then I get how many more from this guy?
3.
Negative 3. So 1 minus 3 of them would be negative 2a e to the t. And I get how many more?
4.
4. So I get negative a e to the t, or no, I get positive a e to the t, minus 2 of them, or minus 3 of them. And then I get plus 4 of them. For a total of 2a e to the t's. How many e to the t's do I have on the right hand side?
4.
4. So what does it tell me?
So A is 2.
A is 2. So my particular solution, this guy, is 2.
Okay.
Now here's the nice thing about this. When you do this process, notice how many t e to the negative t's do you see on the right hand side? How many t e to the negative t's do you see on the right hand side? Any t e to the negative t's?
Oh, no, none.
Turns out that when you add this all up, this term will all go away. These terms will go away. Blah. But what you're left with is, you're going to have this guy. So I have 3b e to the negative t. I have minus 2 times negative 3 is plus 6. Do you see that? Minus 2. Plugged in the term with the minus 3 coefficient could be plus 6b e to the 3 or e to the negative t. Then I have plus 4 times this guy. But how many b e to the t's are here? None. So I just have 3b plus 6b equals 9b e to the negative t. How many of the e to the negative t's do I have on this side?
18.
Negative 18. So b is what?
Negative 2.
And that's your answer. That's your particular solution. Cool?
Okay.
Alright, it's 3:59. I feel like they're going to bitch at you if you don't return the keys, so I'm going to stop the recording.
Okay.
You can ask me more questions when we go back up there.